Okay, so quick recap of what is paper 5. There's two parts, as we have mentioned. There is question 1 and there's question 2. Question 2 is all the graph that I spammed you all last week in labs, also online, and also the homework for the rest of the holiday also. This is what we call data analysis. Okay, and this one, roughly you aim to speed press your calculator. Hopefully over time you're like uncertainty, no problem. That's part of speed press because you want to spend roughly around 30 to 35 minutes max for this. So you can try and see if you can slowly make yourself calculate faster. That will be a goal as you do more practices. That's data analysis, draw graph, plot table. Plot, one mistake. Calculate table, plot graph. Question 2 is the one that's new that we're going to look at today. So this one, I'll just write the times roughly. Will roughly take 40 or 45 minutes. Or at least you want to aim to work towards that. What is this all about? This is planning experiments. You are going to be a scientist to design labs for students to do. That's basically the idea. So today in this workshop, we're going to focus on 3 skills to build. The first skill is how to plan and draft an experiment. Secondly, how to actually write instructions, like writing a lab manual. And third part, how to how to mark your own lab report or your own writings. How to mark. So these 3 things, that's what I'm going to focus on this workshop. We'll divide out across 3 parts. All right. If there's any questions anytime along the way when we're together here, feel free to ask. Okay? All right, let's go into it. So if you scroll into the chat, go into the chat and scroll all the way up, you can find today's P5A. Okay, you can either, if you already have the PDF, you can, I guess, print it out or keep it or just grab a piece of paper and take notes along. So for the first part of today, we are going to look at how to plan and draft experiment and what is question 1. No need to print lah, because it's just instructions only. Okay, so you will see something like this. It's like a question paper. There's no writing space. There's no graphs to draw, no tables. So if you want to print it just to write, you can, but I don't think it's necessary. You can also grab a piece of paper to note stuff. But if you're like, Miss, I want to print so I can note, sure, go ahead. You can also use a PDF attached in Teams. But let's look at this question 1. It's 15 marks to write instructions for someone to do your report. So imagine you're writing this for your friend in school who is a junior, or you're writing it for a younger sibling, or you're writing it for students in the school to do. So you need to be clear, you need to make sense. Let's look at this question here. A student is investigating acceleration of a trolley moving up an inclined plane. You see this trolley is going to go up. At what acceleration? That's what we're investigating. So then they'll give more instructions usually. They'll say, oh, students investigating relationship. Okay, we are testing a relationship between 2 variables. Number 1, acceleration of the trolley. Number 2, the angle of the inclined plane when a force is applied to the trolley. So it's suggested that the relationship is this. Question is this equation legit or not? Is it fake? Is it real? How do we know? We need to design a lab experiment to test the relationship between 2 variables A and theta. Explain how our results can, number 2, most important thing, determine a value for K. So you have 2 things to do in this write-up. Number 1, you need to test this relationship, design a whole experiment. Number 2, we need to figure out how to find this strange unknown K using our gradient or intercept, which is what we do a lot in question 2. So we need to draw a diagram, show the arrangement, and this part usually is just a summary of what to include, procedure, measurements, what variables, analysis of data, and safety precautions. No worries if you have no idea what to write here. After today, we will know what to write in this part. Okay, so first things first. Testing relationship. We need to draw a graph always. And there's two variables, A and theta. Where is A? A is here, okay. Where is theta? Theta is here. Hey, but it's inside a sign. Most of the time, if it's in a sign, you include this whole sine theta. Because you want to take out the theta from the sign, it's going to be a pain. It's just not going to be a straight line. So purpose is, can we rearrange this equation to be a straight line equation? Let's do a bit of rearranging. So I'm going to help you out since the first time. We want, what shall we put on our axis? I think we can do something like divide everything by m. So this will be A equals to F over m minus mg sine theta over m minus k over m. Okay, very good. I have A here already. Now I need to separate out sine theta. Wow, so many things here. Okay, never mind. We cancel out. A equals to negative g sine theta. Everything else, I don't care. I throw at the back. Plus F over m, k over m. We're starting to see a straight line equation. Miss cannot see. Okay, never mind. We rearrange one more time. A equals to negative g sine theta plus this whole thing is just a bunch of constants. Oh, I can put them together. F minus k over m. Okay. So what I just did was the linearizing process. Because now we can see, you want to test relationship of two things, you must plot a graph. So we need to plot. We change what? Hey, what do you all think? Should we change theta and measure acceleration? Or change acceleration and measure theta? Which one to change and see the effect? What shall we change? Think if you're in the lab, you want to see how these two affect each other. Easier to change angle. Change acceleration means what? Wow, a bit hard. I would say change angle. Yeah, I would say change angle. You just tilt, you tilt the slope higher, make it steeper, or then very steep. Yeah. Make it not so steep, then not so steep. Yeah. So I think we will change theta, and then we will see how the acceleration respond to that. So different A when you change theta. Okay, so that means whatever we're going to change, we're going to put it on the horizontal. So we say theta. Then we see, okay, for every theta, what is the angle? Now, the reason why we use sine theta is because you see this y-axis. This is our y-axis. This is our y. X-axis is sine theta. This is our x. A. Y equals to something plus something. This is the straight line equation already. Y equals to mx plus c. This one. So if this relationship is legit, that now allow us to study the relationship between A and theta, we should get a straight line because it's a straight line equation. No square, no square root. Okay. So this one, negative gradient some more. So it probably looks something like this. Like this. Okay, yeah. So you have an intercept and should be a straight line. Then only it's legit. Okay, so we need to explain these things later in the write-up. Like this equation and whether it's straight or not. So here you will have intercept. Number one. Intercept means not through origin. Number two, it must be a straight line. Then only this equation is legit. Okay, we got our equation. Now the trickier part is how do we plan the experiment? Here's my tip. Let's brainstorm together. Then I'll let you all go have some time to go write out some stuff. So when you're not sure how to start, the first few times you can refer to the, let's see, where's my paper 5 set A? There is a template, an answer template that I wrote out for you all. You can find it in the paper 5 set A. I think I printed it out also. You can double check the papers on page 1. Page 1 or 2 or something like that in the paper 5 set 8, you will see this long table. It's a checklist to help you when you just start off. Oh, diagram must have what? Define the problem, must select your variables. Okay. Then your method, or one by one, checklist. We're not going to use it today. We're going to use another one. But this one, when you're doing trying to plan experiment, you can use this to help you plan. Step by step. Everything, make sure you mention. Of course, eventually we cannot bring this into exam, so we'll internalize this after practice, over time. So let's go and look at the things again. What are we measuring? How to measure, how to change data, measure it. Okay, here's my tip. We will look at the equation here and we'll make a list. We will list out every single quantity in the equation and then we'll think through one by one. M, A, F, M again, O, G, okay, G, theta or sine theta, and this unknown K. This is how you can draft before you actually start writing. Just do a very quick plan, okay? Because eventually you need to sort your ideas into this. Hey, which one is independent variable? Which one is dependent? Which one is constant? Okay, so let's keep that in mind while we're looking at this. So mass of trolley. What equipment do we use to measure mass of trolley? Anyone got a name? How to measure mass? What's the name? The thing that you all use in lab for chemistry and physics. Balance. Yes, it's the balance, the flat thing. The official name, we call it is top pen balance. Top pen balance. So I can say use top pen balance to measure. So this is my checklist, just making sure I don't miss anything. So yes, if you do know what is a top pen balance, you need to go Google a bit. That is especially true for paper 5. It's like, miss, we don't have a lot of lab experience. Oh. It's okay. Google is your best friend. So this thing, remember this? Remember this? You press the button, you see the thing. Top pen balance. Okay, next. What else? I think that's it. Acceleration. Oh, how to measure acceleration? Okay, this one we pause first. It's gonna be a bit more complicated. Force. How do we measure force? What is this F? Let's go to the diagram. Force is going to be the force that you pull a trolley up the plane. How do you measure a force? With what thing? What do you use? Any ideas? Newton meter? Okay. We have not used a Newton meter before. We can Google it. Newton meter. Ah, this thing. You hook the thing there and then you pull, then you see the Newton. This is called a Newton meter. Okay. Any term you're not familiar, Google, straight away Google. Okay, we can use a Newton meter. We tie a string like that. We put the Newton meter here and then we pull the Newton meter with our hand. Then here you have a scale. You can read the reading. Yeah, so I'm already planning my diagram to draw later. Okay, and I must label this Newton meter. Actually, there's another way to measure the force where you pull a trolley up the slope. That is actually using a pulley system. So alternatively, you say, I want to know the force exactly. This one I use my hand to pull, or maybe it's not stable, not steady. You put a wheel here, you tie a string, hang it to a mast. This string is heavy, mg, or some force. So mg will be the force that pull this trolley up. There is also another acceptable method, pulley method. So this mg is for your force. Two methods here, okay. Later you have to choose one. So where were we? Force, we pull the thing up. So this one you can use Newton meter. Or you can use a pulley system. But you must describe in detail how does this pulley system help you find the force. G is a constant, 9.81. No need to find. Theta. I think just now, who mentioned earlier, use protractor. No, easier to measure theta. Okay. Theta, you use protractor, which is this thing. Remember this? Here got a lot of numbers. That's your protractor. So use protractor. Okay, we're almost there. Last one, K. Before we go to acceleration. Dun, 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 dun. K is some constant, right? Let's go back up. Determine a value for K. We need to use your results to determine a value for K. Results means our graph. Remember, we plot points, we plot error bar, usually lah, then we fit line. So that means you have some intercept, which is f minus k over m. So usually, if you want to find k, you have to say the y-intercept equals to f minus k over m, and this is the one we want to find. That's the purpose of collecting our data. Yes, to be calculated. So we need to include an equation for that in terms of our intercept. So you have to rearrange this. M times intercept equals to f minus k, which gives us k equals to f minus m times intercept. Y-intercept. So should include this also. Just edit this a bit. K equals to f minus m times y-intercept. This equation must mention later. Because they ask us how you use your result. Say, oh, I use the equation to find. Okay. Now the last one is the challenging part. We pretty much know all the other equipments, but except for acceleration. How do you measure acceleration? This one a bit more, few more steps. How does one measure acceleration? Can it be measured directly? F over m. Okay. Potentially. But it's a bit complicated if you use F over m. Let's say here got acceleration, no? You're gonna have a force. You're gonna have a force, weight, some pulling force, maybe also some frictional force. And we don't know much information about this force. So it's a bit hard. Although it's a good idea, Alan, because we can use F equals to ma. If we know these two, we can find it. But we don't know net force, we need to know all the forces. We don't know this one. Friction. They got talk about friction? No. Too much unknowns. Put an accelerometer on the cart. Potentially, but how does the accelerometer work? Usually, if it's a traditional experiment, imagine school lab equipment don't have so fancy accelerometer one. I know our phones are quite fancy. All our phones actually can measure acceleration straight off, but school equipment, I think cannot. I think it's accelerometer. I think it's correct. Unless it's British spelling. I don't know. Okay, so good ideas, but not enough information for this one. If we use accelerometer, a little bit too high tech. That's like, oh, we just put accelerometer here and measure. Can, but too advanced. So here's a tip. What you can do with traditional lab instruments to measure A. Method 1. Let's write it on the left side. Light gates. How do light gates work? We can add that to the list. Method 1 is actually to use our good old stopwatch to find acceleration. How is that possible, miss? Well, possible. Wait. See. Let's assume the trolley released from rest at a point. So at this point, let me hear, the trolley will be at initial speed 0. So this is released from rest. This method is a bit agak-agak, but can use. Then you can say, oh, how long does it take to come to this point with a certain final speed? Okay, you would have traveled a certain distance, and you would have taken a certain time to travel from here to here. So if we think of that, we say, actually there's a Stuva equation we can use if we make some assumptions. If we assume you start from rest, you release, the trolley go up, and the same time you start your timer, this whole thing is 0. So that means if I know the distance it travels, I can find the acceleration if I know the time it takes to go from here to here. I know this, I can find acceleration. So this is one method. Got a lot of error one because you have to time the thing and you have to pull the trolley, but it's still a legit method that students can do in labs. So you can say acceleration is 2s over t squared. You can use this to find acceleration. But you must mention, well, how you measure t and d? Oh, use stopwatch to find T. How about S? Oh, use ruler to measure distance travel. A bit hard to do, but possible. Okay, this is one method. Method number 2, little bit more advanced, but doable in labs, is to use a light gate. So this is the light gate method, which is good to know because we'll be using it a lot. Light gate. What is a light gate? Some of you may have seen it before, some of you may have not. Google is our best friend. Ah, you see this? This is a light gate, U-shaped friend. Why is it U-shaped? So that when something passes between the gate, there's actually a laser beam here, the light gate will detect, hey, somebody passed through. It's a gate of light. It's a gate of light. Now, in real life, it's something like this. Make it a little bit bigger. Okay, here we go. So light gate actually has a beam of light. That's why it's called a light gate. When you pass through the gate, it will scan and it will say, oh, somebody went through, somebody cut our beam. You interrupt the beam with your trolley or car, whatever that is. And this light gate, usually you use it to measure time, and from time, use to calculate velocity. Okay, bear in mind this light gate. In real life lab, it looks like this. See the light gate? Okay, so if we can put a light gate to measure velocity, we can find acceleration when the trolley pass by. Okay, let's look into it a little bit more. How does this work? Okay. So we have initial speed. Doesn't matter what speed it is. You can put a light gate here. You can put another light gate here. Then, if you have final speed, initial speed 2as, we can find acceleration if we know the distance between the light gate, the initial speed, and the final speed by the light gate. This is the method of light gate. So A will be, rearrange, v squared minus u squared over 2s. But this method is a bit more tricky because we need to break the beam. Because remember, light gates is shaped like this. And then got a little beam coming through. And it will only measure time. These light gates, they only record, or not measure, they record time. But you want to use the light gate to measure velocity. So we need something to interrupt the beam. Otherwise the sensor won't trigger. Yes, correct. This trolley may not be able to fit into this beam, but we can put a piece of card on the trolley. This card, how to draw? Card with a certain length. So then the card can nicely go through this light gate. Then the trolley is down here with the wheels like that coming out of the screen. Okay, so in case your trolley is too big, cannot go inside the gate, at least the card can definitely cut the beam, interrupt the beam. Okay, I understand that you might be feeling a bit strange like, Miss, I don't understand this light gate. How does the light gate actually work? I'm gonna grab my flashlight. Give me a second. Y'all can do this also. I need you all to open your eyes big. Grab your phone, open a timer, please. Open a timer on your phone. Okay, see this light, right? Yeah, can lah. I will off my background, virtual background also. Like this. Ons! I'm going to take a selfie. No, I'm just kidding. I'm not going to take a selfie. So here is, if you can't see my picture big enough, you can just click on my picture. It should full screen that and swap with the thing. So what I want you all to do now is, if you have your timer on your phone, you see this light? I'm going to interrupt the light with a book. A nice, I guess, a SEM3 lab manual. Why not? See this book? So at some point in time, you will not be able to see this light. I need you to take the time how long. Okay. So for example, the book will come in. The moment you cannot see the light, you start timer. Then when you can see the light, you stop timer. Hopefully I did that slow enough. Now just by doing that, you taking time, you can know how fast I move this book. Because you are the light gate. You see this light? Okay, I do one more time. Okay, this one I'm going to do proper one. Just now was trial. Okay, everyone grab your timer. You're going to let me know what time it is. I'm going to calculate the velocity of the book. Ready, yeah? Ready, yeah? The moment the light you cannot see already, you start timer, okay? So ready, go. I try to move at the constant speed. Okay, I try. All right, light gates, are you all ready? 1, 2, 3, let's go. Okay, how many seconds was that? Fellow light gates. What did you get? Three seconds. Okay, first light gate. 0.42. Wow, our random error is very big. Never mind, it's okay. We are online light gates. 3.05. Wow. Alan and Roshan, you all got the same value. Okay. Any other light gates plus? Wow, got uncertainty some more. Oh, yo. Okay, some more. We'll take the average lah. Average looks like it's gonna be 3 point. Okay, let me do a quick average. 3.05, 0.42. Are you sure it's 0.42? Ian, yours is super fast, way. The second time, 3.3. Maybe I'll consider anomaly. 3.36. Zhengxuan is 3.39. Okay, I think that's good. Good collection. Thanks for sharing your data. 1, 2, 3, 4, 5. Okay. So I'm going to divide by 5. Oops. Average is about 3.2 lah. Okay. So just now your measure, it takes an interval interrupted 3.2 seconds. Plus minus. Okay, got uncertainty. You'll see all your values all 大概 roughly there. And if I say this lab manual, I measure the length. I'm going to give you all the value. I'll just take my ruler, put it. This is 30 cm. Okay, very good. Nice measurement. The length of the card is 30 cm. How much is the velocity that I moved my book at? Average. It takes 3.2 seconds for a 30-meter length to pass through a point. Like this. 1, 2, 3, and then break. You see? It's a different way of measuring velocity. This is your good old Stuva, but used in experimental technique. Hey, this is the one people use to get saman on the highway if you drive too fast, okay? They put the camera, police put the camera there, you drive past, they already know how fast you go. Because they know estimate roughly how long is the average car. So this is your length of your cart or your car if you're speeding down the highway. If you just learn to drive, don't speed. You want to find the average velocity during this time period. You get 9.4, 9.375. Okay lah, let's say 9.375. How do we get that? That will be the distance over the time taken. Just put T lah. So this one you just divide lah. So you take 0.3 meter or cm also can. Okay, let's do cm. 30 cm. And how long does it take? 3.2 seconds. Okay, so we get 9.4 cm. This is how you use a light gate to find velocity. If you didn't know this before, it's a good one to write down. Okay, because we'll use it a lot. Light gates. Remember, don't speed. Don't speed too fast, above the limit. Who knows, they may be light gates. They are tracking your speed. They use a different technology actually. But never mind, let's get back to this. Okay, so you can say measure speed with light gate. We have 2 here, and you must talk about the details. Put a card, measure the length of the card, measure how long it takes for the light gate to pass through, for the card to pass each gate. Put it that way. Okay, so there's 2 methods for acceleration. There is flexibility in you choosing which one to talk about. All right, I think that's pretty much it. Planning the experiment. We have kind of a rough idea of what we can do. So let's see 2 methods. Now it's time for you to go try and write it out. How to write it out? Okay. You will see an empty page with a lot of boxes and bullet points. This is the template to guide you along. So instructions are in blue. You will replace the instructions with your typing. So now it's speed type. You and your members, if there are any members with you here, you're going to speed type, put together all the information as much as you can in a sequence, something bullet point sequence. Don't write some long essay. This is physics. We like short, concise bullet points, but you must make sense. Okay, so what are we aiming for? Follow template, bullet point, clear. Got to organize these ideas for a instruction that people can follow.